Welcome back, Algebra 2. We're in lesson 111. We're going to talk about word problems that give us 3 variables instead of 2. We're used to using number of nickels, number of dimes, or number of dimes, number of quarters, or just 2 of the 3. Now we're going to actually use 3 of those. So let me put the first problem up here and we'll walk through it. So in example problem 1, we are given 3 variables: the number of nickels, the number of dimes, and the number of quarters. And in this first part here, we are told that their quantity, our quantity statement, is going to be the number of nickels plus the number of dimes plus the number of quarters is equal to 26. Just the quantity of, the count of each of those types of coins. They were all in a jar, and their value was $2.25. So now we can apply a value equation to this. So we just put in the value. We know that a nickel is worth 5 cents. So 5 times the number of nickels plus 10 cents. So 10 times the number of dimes, and 25 times the number of quarters is going to equal, and we always write this in penny format, the number of pennies, 225. Okay? Otherwise, we'd have to put this as 0.05, 0.10, 0.25, and then we could write that in the dollar format. It's just easier to do the math if everything is in a whole number instead of a decimal. So that is how we write the value statement. Now, we could easily take 2 of these away and bring them over here, like subtract 2 from this side, maybe the number of dimes, the number of quarters, and say the number of nickels is equal to 26 minus the number of dimes minus the number of quarters. But then we would have to do that again for the number of dimes. The number of dimes would be equal to 26 minus the number of nickels minus the number of quarters. So we would need 2 more equations, right? So we've got this as well. But this gives us an opportunity for a third equation here. So there were 10 times as many nickels as quarters. So the number of nickels, there were 10 times the number of nickels as the number of quarters. So 10 times the number of nickels is the number of quarters that we have. Right? Is that right? No, that's not right. If there were 10 times as many nickels as quarters, then I would need to say 10 times the number of quarters, right? Yes. So 10 times the number of quarters is how many nickels there were. So that, sometimes you have to talk it out loud, All right, so now we have 3 equations, and we have something we can substitute n in for nn. So why don't we do that? Let's rewrite it as 5 times 10 NQ plus 10 ND plus 25 NQ equals 225, right? So we can do that, and we'll get 50 NQ plus 10 ND plus 25 times the number of quarters is equal to 225. Now I can put these 2 together, and I have 10 times the number of dimes plus 75 times the number of quarters is equal to 225. Right? And if I substitute this in for the number of nickels here, I've already subbed it in here. Let's sub it in here as well. So I'll get 10 times the number of quarters plus the number of dimes plus the number of quarters, because I substituted NN, this for NN is equal to 26. So now I can combine these and say the number of dimes plus 11 times the number of quarters, because this is a 1 here and 10 and 1 is 11, is equal to 26. Now I can use these 2 in a elimination, right? So let me do that. Let me multiply this times negative 10. And I can write negative 10 times the number of dimes minus 110 times the number of quarters is equal to negative 260. And now I'm going to write this here below, 10 times the number of dimes plus 75 times the number of quarters is equal to 225. Now I can cancel these. This is going to be 35, negative 35 times the number of quarters is equal to 35, negative 35. So the number of quarters is just equal to 1. So now I can start subbing that in. The number of quarters is 1. And if 10 times the number of quarters is the value of NN, then I know that 10 times 1 is 10. So 10 plus the number of dimes plus 1 is equal to 26. 10 and 1 is 11. So the number of dimes is equal to 26 minus 11 is going to be 15. So now I have the number of dimes, I have the number of quarters is equal to 1, and the number of nickels is equal to 10 right here. All right. So what I did was we found this bit right here. There were 10 times as many nickels as quarters. That allowed me to create this equation, which created a substitution value for NN. Then I was able to take that and drop it in here. And I was able to take that and drop it in somewhere else. In here. That's right. I dropped it in here. So the two values of NN, I was able to drop in 10 and Q. And then that got me to a point to where I could do some elimination and then solve for NQ, which then allowed me to go back in and apply it here and here in my original formula to give me the total number of each one of the numbers of dimes, quarters, and nickels. All right, let's look at 111.2. All right, this time we're not using quarters, dimes, and nickels. This time we're just going to use objects. So the total number of blues, greens, and yellows in the pot was 7. There is our first equation. So the total number of blues, greens, and yellows in the pot was 7. So I'm going to say blues plus greens plus yellows is equal to 7. The blues weighed 1 pound each, so 1 times blue plus the greens weighed 4 pounds each, so 4 times the green plus the yellows weighed 5 pounds each, so 5 times the yellow. The total weight was 25 pounds. All right, so we have 2 of our equations. Now let's do our third. If there was 1 more yellow than green, how many of each were there? So yellow is going to equal green plus 1 because there's 1 more yellow than green. So however much green is, yellow is 1 more. So green plus 1 is yellow. All right, so we have something we can substitute in for y. So B plus G plus the value of y, which is G plus 1. G plus 1 equals 7. So B plus 2G equals 6 because we subtracted 1 from both sides. Right, so now we have a new equation. So let's subtract y in here, right? So here's our other statement. We have 1 times b plus 4 times g plus 5 times, and y is g plus 1 equals 25. So now I have 1 times b plus 4 times g plus 5 times g plus 5 is equal to 25. So I can combine that and say 1 times b plus 9 times g is equal to 20 because I subtracted this 5 from both sides. Now I have two statements. So I have 1b and 1b. So I think I can just multiply this. Let's multiply this one times negative 1. So times this whole thing times negative 1, and I'll write it over here. That'd be a negative b minus 2g equals negative 6. Let me bring this one up here. 1b, positive 1b, plus 9g equals 20. Cancel. This gives me 7g is equal to 14. So the number of greens was 2. So now that I have the number of greens, I can go back and substitute in here. Actually, I can find the number of yellows pretty quickly. I can just substitute 2 plus 1, so that equals 3. So y is equal to 3. So now I can go back into this very first statement. B plus the number of greens is 2, plus the number of yellows is 3, is equal to 7. This is 5. B is equal to 7 minus 5, which would be 2. So B is equal to 2. Check my answers right quick. And they are correct. So you can see how we did that. We created some value statements, a quantity statement, and then another evaluation statement based on logic, right? And that was the y equals g plus 1. All right, and that is all we have for lesson 111. I will see you in lesson 112.